Let's talk about energy changes associated with phase changes based on a phase diagram. Consider the substance given here with this phase diagram. What information do you need to calculate the heat that you need from point A, from state A to state B, state C? What information do you need, okay, to determine how much heat is it going to take to bring it from temperature TA to temperature TB? You remember the formula? Q for no phase change, just temperature change, would just be equal to 1. What's the formula for Q if the only thing happening is a temperature change? C delta T, right? C of the solid. What is C? What do you call C? Heat capacity, right? Of course, chances are if you look that up, it's given to you per mole, so you have to multiply the per mole value by the actual number of moles, okay? Now, from point B, what happens from point B at point B? It turns from a solid to a gas, right? So what happens then? So this is Q for heating from TA to TB, right? So this delta T would be TB minus TA. At point B, what happens to it? Q for the second leg of your second step in your process would be what? Changing from a solid to a gas, what happens? What's your Q there? What information do you need to look up? You need to look up the delta H of sublimation. Okay? Delta H sublimation, and that might be given to you on a per mole or per gram basis. So you have to multiply it by the actual number of moles or amount in grams. So that's the second step. What's the third step here? In the third step, you're going to raise the temperature from TB to TC. Okay, once you go from TB to TC, what's the form of your substance now? It's now a gas, right? So you need the heat capacity of the gas times delta T. And again, heat capacity might be given per mole or per gram, so you multiply it by the actual moles or grams. All right? What would Q versus T look like? Amount of heat versus temperature. I start off at T sub A. Okay, I'm going to start at T sub A. Okay, what will happen when I go to T sub B? The higher the temperature, the more heat I put in, the higher the temperature, right? What happens if I keep heating at temperature B? So this is going to be, this difference right here is Q1. What happens at temperature T sub B? It will sublime, right? While it's subliming, the temperature will remain constant. So temperature constant means you get a vertical line, right? So this amount right here, Q2, is the delta H of sublimation. And what happens when the gas has been the solid has been transformed into a gas completely? Keep heating it, temperature will start going up again. Okay, so this difference right here is Q3. Okay, should be able to do a curve like this. This is called a heating curve, right? For a substance that sublimes. Okay, what would it be if it were over here? Then you're going to have the heat of fusion, delta H of fusion, and then you have to have delta H vaporization. Okay. Now, what if I were to plot temperature versus Q instead? What would it look like? Temperature TA is going to go to temperature TB, right? And then what happens? You keep heating it, the temperature remains constant while it's subliming. This is sublimation right here. Okay, let's see. So this one right here we say is Q1. And this thing right here would be Q2, delta H sublimation. And then once everything's turned into a gas, the temperature goes up again. Q right here is going to be equal to Q3.